Okay, so let's discuss a paper soon after reading it. In this podcast on YouTube and recording, we selected a paper and started reading it 2 hours ago. And from now on, we are going to discuss the paper. And today we have 3 participants. I am Yota Kashima. I'm a research assistant at ATR Monash University. And next, Aniko, can you introduce yourself?
Yeah, I'm Aniko Kustor. I'm a PhD student at Monash University.
Then Ryoichi, please.
Yes, I'm Ryoichi Watanabe at the Kyoto University and a PhD student.
Okay, thank you. And today we are going to discuss a paper titled Decoding Rapidly Presented Visual Stimuli from Prefrontal Ensembles Without Report nor Post-Perceptual Processing. And the author is, I think, all from a French Institute, and Joachim Bellat, Marion Gay, Abulihash, Duara Kana, Becca Yala, and Timo van Kerkorië, Stanislas Dion, and Theophanis Panagiotaro. So sorry, it's a bit it's really hard for me to properly pronounce these names, but just forgive me. But anyhow, this paper is published this year, 2022, from Neuroscience of Consciousness. Okay, so first I will give you just a brief summary of this paper. So in consciousness research, there is a kind of ongoing debate regarding the core region for consciousness. So some people or some theories predict that the prefrontal cortex is important for our subjective conscious experiences, but other people predict that the posterior parietal or sensory area is important for consciousness. So this study is specifically focusing on the prefrontal cortex. And then if the prefrontal cortex is important for conscious experiences, then we should be able to decode the contents of the conscious experiences from the neuron operations in prefrontal cortex. But, okay, so the reason why I think the main point of this paper is that they used a no-report paradigm, because previously some people who supported the posterior core hypothesis says that prefrontal neuron just reflect the post-perceptual processing or task-related processing, not the neural correlates of consciousness per se. So this paper investigates that activity in prefrontal cortex in a no-report paradigm. And what the author did is basically record the population of neuron from macaque ventrolateral prefrontal cortex in 2 conditions, and both of them are this no-report. And in one conditions, the authors presented a sequence of images in slowly, and the other condition, they presented the stream of images in a rapid manner. And then in both conditions, again, they recorded the brain activity or neuronal activities, multi-unit activity from prefrontal cortex. And then they found that prefrontal cortex encode these visual informations or visual stimuli. Also, interestingly, they found that the activity is decodable, or the stimuli was decodable at earliest roughly around 60 milliseconds after the stimulus onset. And the performance was roughly a maximum at roughly 150 milliseconds. And also they recorded the activity not only in prefrontal cortex, but also in posterior parietal area. Then they found that the decoding accuracy was better in prefrontal cortex than posterior parietal cortex. And then the end, they kind of concluded that the neurons in prefrontal cortex encode the conscious perception or conscious experiences without no report paradigm, suggesting that this is the evidence or the support the theory that predict that prefrontal cortex is important for conscious experiences. And that's my just a brief summary. If you have any questions, comment, can you please do it now?
Yeah, I had one question, which is somewhat related to the methodology, but also to the interpretation of the results. So in the discussion, the authors claim that this participation of the prefrontal cortex or neurons in the prefrontal cortex may be actually a sign of that the prefrontal cortex has this facilitatory role in top-down predictions, communicating towards the primary visual areas. And this is also kind of supported with the time course of the successful decoding. But so I understand that they have used different objects, and as I understood, they use it randomly. So they chose randomly among from at least 18 objects, I guess. And I wasn't quite sure what was the prefrontal cortex predicting there, or like how, because I mean, in general, I would assume when we are talking about predictions, it is coming from a previous some kind of regularity in the environment, or some kind of learned rule or something like that. But then when you get random objects, yeah, I wasn't sure what was it predicting. Maybe was it like just very quickly from the outline of the object predicting the exact object through learning, like, I don't know, did you understand this part? And can you explain, or what do you think?
Okay, so I think I can answer that question. And when you say prediction, or when the author say prediction, it's not about the across trial or across stimuli prediction. Within stimuli, one stimulus prediction. And I think it's kind of better to think about the two different pathway or parallel pathway. One pathway is so-called a feed-forward sweep. It's really first, so it leads to prefrontal really quickly. And then the other one is somehow slow relative to the first one. And then you can, and if we think about these two, pathway, then you can imagine that the first sweep, feed-forward sweep, first reach prefrontal, and then that will, or the activity at the prefrontal caused by that feed forward sweep will be then feed back to the sensory area or other area. And then that's top-down input, and also the slow neural processes will meet at some sensory area or temporal area, for example, inferior temporal or something. Then that kind of informations are combined for better object recognition, something like that. Does it make sense?
Yeah, that makes sense. And then in this way, basically, like a very perhaps not as rich information stream goes up to the prefrontal cortex, and then it kind of basically generates some predictions of the possible objects, and then that will facilitate the processing in like higher visual areas like V4 and others, right?
Yeah.
I see. Yeah, that makes sense.
Any other questions or comments? Ryuichi, do you have any?
Yeah, I have a briefly comment and question. So in this study, the two macaque participated in this task. So this sample size or a trial size is enough for concluding these significance. So just I'm wondering this point.
Yeah, that's a difficult to answer, I think, question. But at least, of course, you need to think about the cost of, data acquisition. From ethic perspective, it's not in a sense good to, invasive brain activity from many, monkeys.
Yeah, I see. And and participate name or participate ID, just macaque A and macaque H. So H, A and H, what means? So if the normal A, B, C, D, E, F, G, H participated, but successfully A and H, or how randomize the name?
No, I think it's just their name, and then they just, yeah, right, because I'm pretty sure they named the monkeys, the researchers are working with them. So
so the OSET or the institute have some macaque monkeys, and in this study they choose macaque A, and after macaque H. So to participate, two monkeys participated in. Yeah, I understand the difficulty of the animal study or ethics, but
I don't.
So yeah, I'm not sure actually if I understand. So are you concerned that these findings are not generalizable to like all mammals, or because I think even with a single experimental single subjects, if we are actually collecting good quality data, that can be very informative. Like we had so many important findings identified based on, so these important case studies with different lesions and such. In that case, I think it's like if the experiment is well-rounded and the methodology is sound, it's not necessarily obvious for me why would you need a larger sample size.
Yeah, I see. Yeah, just my comment.
But at least based on the figure 1, for example, the decoding accuracy is, obviously high. than chance level. So you don't need to think that much about the sample size and also effect size and things like that, I guess. But if I check them supplementary material, like a figure 1, which is from Monkey H, the decoding accuracy. And there, the performance was, not that good as the figure 1 in the main text. So I don't know.
Well, what does figure 1 in the supplementary shows?
It's basically the same as, sorry, not the figure 1. Figure 2 in supplementary, figure 2 in main text. So the x-axis is the time from stimulus onset, and then y-axis is the decoding accuracy. So the supplementary material shows the decoding accuracy for each stimulus. Probably not the supplementary material 1. Probably 2 or 3. I forgot the number, but just same decoding accuracy. Supplementary material 1. Yes. Yeah, probably I can show you or share by sharing my screen. And this one. Basically the same. If you look at the y-axis, performance or the max is roughly like a 0.12 or the max is 0.5 in this figure. But let's say if you go back to the main text, the max is like 5, 0.25 and 5 and sometimes 1. So overall, I would say that the decoding performance is better for this Monkey A than in Monkey H.
I'm not sure because I think the difference. So in the main figure A is trained with isolated stimuli, and then in the supplementary it says trained with slow-paced stimuli. So I'm not sure if it's actually different monkeys. Are you sure it's that?
Yeah, so I did not explain my brief summary, but in Monkey A and Monkey H, the task the conditions were slightly different. In Monkey A, there is 2 conditions, and one is isolated condition, meaning that within one trial, I think 500 milliseconds, they show only one image with 17 milliseconds. So single stimulus trial. And this is what they called isolated stimuli, I think. And then the top is rapid sequence serial visual presentation trial. So within 500 milliseconds, they shows like sequence of images. And this is for Monkey A. And then Monkey H, that basically what they did is similar. But then here they consider 2 different conditions, slow-paced trial and again the RSVP trial. And then time window is different, the duration is different. And also in Monkey H, for both conditions, within one trial, they presented, series of images with different time durations. So supplementary material, they use slow-paced trial because this corresponds to, in a sense, the single stimulus trial, which is isolated stimuli in figure 2.
Oh yeah, okay, now I get it.
Yeah. Stop share. Yeah, I did not explain that, but yeah, I don't think whether that differences in condition between two monkey explain the difference in performance, classification performance between monkey and monkey hedge. But I think overall, the performance, or at least they found some kind of increase in classification performance for both monkey A and H. So their conclusion, in a sense, solid or robust, I would say. But probably my, understanding is wrong in terms of the, task conditions. So. And any other questions, comments? Okay, so if not, let's start discussion. Do you wanna start some, or do you wanna say something? Or otherwise, I will have some, comments or questions for the discussions.
Yeah, go ahead, I think.
Yeah, so my question is in a sense related to Aniko's first question about the top-down and bottom-up, that kind of, processes happening in the brain. But in this study, they showed that the classification performance is better in prefrontal than in PPC, posterior parietal cortex. Then I checked the time point where the maximum, classification performance was obtained for each regions. And then seems like for each region, the maximum classifications is almost at the same time, reached almost at the same time. But if that's the case, then how, can we interpret this? Because my understanding is that even though that, there are some, interactions between prefrontal cortex and posterior parietal cortex, I imagine that the posterior parietal should be, input or send an input to prefrontal cortex for conscious, experiences, I think. So that means that the maximum classification performance will be reached earlier for PPC than for PFC. But they shows that almost the same peak for both regions, or probably I don't know, almost the same, but slightly slower or later for PPC instead, not the PFC. And I don't know whether how we can interpret that. Or does they, because if they think about some kind of neural processes in parallel pathway, or the interactions, or that kind of complex relation between prefrontal cortex and posterior parietal cortex, they might have some kind of prediction about that, but they did not, at least I could not find any sentences explaining that kind of temporal difference between the prefrontal and posterior parietal in this paper. So that's my kind of questions or comments on this paper. What did you think, or did you find that point as well?
Firstly, I agree with your question, and so in this study, they also discussed this point, right? So why the prefrontal cortex to activation or sensory is better than the PPC. That's firstly the more quickly pathway of the visual information, like the magnocellular or the this one, and not also there are the visual perceptual pathway, not only the post-perceptual cortex, but also the thalamus and so wait, I forget the name. So not only the perceptual cortex, but also the visual information and the thalamus and the subcortex and the amygdala pathway and the prefrontal pathway. I think it's more quickly than the normally perceptual pathway. So I think the authors discussed this point, and the prefrontal cortex activation is much faster than the PPC. But I also wondering, this quick activation is not represents the detail of the visual cortex or contents of consciousness. So I agree with the activation of the PFC is faster than the PPC, but this early activation didn't. I can't believe that this early activation represents the content of the consciousness. I think, and this represents as the author said, quickly decoding or quick judgment, not only the detail, but this is not the detail of the decoding, but the rough decoding of the visual information.
So you mean just the decode gist of stimuli?
Right, like this. I think they also discussed this point.
I don't know, but by the way, this is the figure from supplementary material showing the classification performance in PFC and PPC. And what I mentioned is that the peak of blue and yellow, for me, looks like PPC, the peak is later than the blue line, PFC. And I don't know how we can interpret this. And monkey hedge, probably the peak precede in PPC than PFC, but not for monkey egg. So I don't know how the author interpret these results. And another thing is that in this slide, the author shows the performance from PFC and PPC, and then they selected the channels based on the activity during from 100 milliseconds to 200 milliseconds after the stimulus onset. So if they observe some increase or decrease in that time duration compared to the baseline pre-stimulus duration, they consider or include these channels. But if I don't know whether that kind of bias, that kind of channel selection bias the results, specifically this result, because again, the PPC, I imagine that then they encode the information earlier than PFC in temporal or in the time scale. So probably there is some, important information channels for PPC, but I don't know. At least they provided or make their data publicly available, so we can, check or analyze their data by ourselves. But, that's kind of my question, all about the, timing of neural processing. It's really complicated, but at least they consider two different brain regions. So I don't know what the prediction of the author on the these timing of these regions. Yeah, that's kind of my questions or comments for this paper overall. Does this make sense, or?
Yeah.
Any other questions? So basically, yeah, as Nico mentioned, that I am really interested in the different pathway and the timing of neural activity for this. So again, I was really interested in that kind of aspect, or what the author predicted about that while reading, this paper. But I think paper itself was, in a sense, clear. So probably we don't have many to discuss, but one thing is that it's kind of interesting that then in the last section of discussion, they mentioned the representational similarity analysis and the Krieger-Scholtes, approach. And then that's something related to chorea structure, approaches. So in a sense, consciousness researchers, start to think that kind of approach is important for consciousness. That's interesting.
Yeah, I see that.
Any other comments, question? I think we've already discussed this paper roughly like 30 minutes or something. So if nothing else, we can finish discussion here. You fine?
So I have a briefly comment a question. So in this study's results are this study supports not only GNWT but also IIT. So they also mean that the PPC also are activated and predict the visual experience. So this point supports an IIT, and also prefrontal cortex also important for like the identifying the or decoding the visual information. So so prefrontal cortex, the result of the prefrontal cortex decoding supports the GNWT. So the authors, how did the authors want to discuss the relationship between this result and these two theories?
So I think at the first, their aim is, or they wanted to test the role of prefrontal cortex. So their assumption is that if prefrontal cortex really related to, conscious or contents of consciousness, then we should be able to decode the stimuli or the contents of consciousness from or based on neural activity at the prefrontal cortex. That's the assumption, the main assumption. And at the same time, they also investigated performance, or they also checked the classification performance at the posterior parietal cortex. And then they found that classification performance from prefrontal cortex is better than PPC, posterior parietal cortex. And then they suggest that or if that's the case, then the PFC seems to encode the stimuli more accurately than the PPC, meaning that content of consciousness might be highly correlated with activity in PFC than in PPC. And they compare the two theories in the discussion, so they did not say anything that strong, like IAT is not true or something. But they just, showed their interpretation regarding the two theories. Does this make sense?
Yes, I see. These theories cannot explain this quick PFC activation, right? I think as the author discussed.
Cannot explain.
So normally, according to GNWT, the graduation and the threshold of the brain network activation, right? Posterior and prefrontal parietal net, posterior and prefrontal cortex and global ignition. So there are the stages, but in this study, the study shows that the prefrontal cortex is much more earlier activated. So this result did not support or did not this result is incongruent to the stage of the emergent consciousness according to of the GNWT, right?
I think they support, or at least they say that this result support the global neural space theory.
Yeah, but so the earliest prefrontal cortex activation is, I think, incongruent, or incongruent is missing. So the prediction of the GNWT
okay, so I think I kind of understand what you try to say. So according to global neural space theory, once some information enter the global neural space, then it should lead to conscious experiences. So no matter or regardless of the amount of information, once that information enter into global workspace, then it should be consciously perceived. And if that's the case, then that early activity at the prefrontal, or first of all, if we consider or if we assume that the prefrontal cortex is kind of global neural space, and then if some activity reaches the prefrontal cortex or global neural space theory once, that should be consciously perceived. Is that what you try to say?
Yeah. I see.
I don't know.
Isn't that the global neural workspace? Maybe, if I recall correctly, more recent papers were suggesting global activation, not specifically at the prefrontal cortex. Like an extended network of activity. Aren't they?
Yeah, but still, I don't understand what the entrance of global neural workspace mean. Like, what, it's not like a binary separation, either 0 or 1, like or now enter or now not, in the on the stage or something like that. Because if we think about that kind of binary separation, then there is no like a early or late kind of argument probably.
Well, I think there's a lot of issues with kind of mixing all of these together, because you have like whether you can decode some activity, like decode something and categorize something from neural activity, but then how is that relates to actually having a conscious experience, and how is that relates to having a conscious experience and being able to report about it. I think it's unclear. I think you can potentially, better than chance level decode many things from the brain. And then there are several, so many studies doing this kind of decoding work. But I'm always, trying to be very cautious about assuming that what this decodability means. I mean, I don't know if the authors actually suggest that decodability means much more than that.
I see. Yeah,
I see.
But I don't know.
Yeah, that's really important point. I think. So there. Yeah, that's very important point, I think. And any other comments, Yuichi?
I'm okay.
Okay. So should we stop here? Okay. Then see you next week. Bye-bye.